Welcome to another PCEP Prep session. In this session, we're going to reinforce some of the most fundamental building blocks of Python, that is, variables. We'll cover how to assign, print, and reassign values, as well as talk about naming rules and different data types you'll encounter. These skills directly map to multiple PCEP exam objectives, so mastering them is critical for your success. Python's simplicity hides strict syntax rules. Case sensitivity means that capitalization changes meaning. We talked about variable with a capital V is different than the variable name variable with a lowercase v. Those are two entirely different variables. Indentation defines scope. Don't mix tabs and spaces. Remember, this is how Python defines code blocks, not using braces, but using indentation. Function calls always need parentheses, even if no arguments are passed. You'll see the print function, built-in function, used throughout the PCEP exam. PCEP questions often show tricky syntax errors. Knowing these details lets you spot the problems instantly. So the more familiar you are with the semantics and the syntax for Python, the better you will do on the exam. When it comes to assigning, Python reads right to left. It takes the value on the right and stores it in the variable name on the left. This is not mathematically equality. We're actually assigning a value to a variable. Remember, in Python, the variable actually is a pointer to a value in memory. For the exam, expect to identify what's valid versus what's not. Always use meaningful names that describe the data's purpose, like alert underscore message or source underscore IP. Remember, variables can start with an underscore or a letter and can contain underscores, letters, and digits. But remember, they cannot start with a digit, only the underscore or letter. The print built-in function outputs data to the console. Notice how we can combine literal strings and variable values. It's very important to understand the two parameters sep and end. The sep parameter sets the separator between multiple items. This defaults to a space. The end parameter sets the end line character for the print statement. This defaults to a new line. Also, forgetting the parentheses or mismatching quotes are frequent exam traps. In cybersecurity scripts, the print function is often used for logs, alerts, or debugging network data. So get comfortable with using the print statement. As stated, it will be used through multiple questions on the exam. In Python, a variable can be reassigned anytime its previous value is replaced. On the exam, you might see code where a variable is redefined and you'll be asked for the final output value. Always track the most recent assignment. Let's take a look at this small example here and talk about some of the pitfalls with assignment. I'm going to go ahead and jump into Python shell here, and we'll create a variable called IP address and assign the value 192.168.1.1. If I print IP address, we get the expected outcome of 192.168.1.1. Now I can reassign IP address anywhere throughout my program. And if I print IP address, now it has the new value 10.0.2.1. What I want you to understand is strings are immutable. So if I look at the ID and print that in hex of IP address, oops, I need hex on the outside. And let's go ahead and use a print call. You can see here's the address where IP address points. And in that memory address, in that memory location, is the value 10.0.2.1. Let's go ahead and reassign IP address to another value and then print the ID again, which is the memory location, and you can see that memory location changed. Strings are immutable, so there's a new memory location is allocated and the new value stored in that new memory location and assigned to the variable. Something to be aware of. The PCEP won't go in great detail for testing that, but that is really what's happening behind the scenes. So when you're taking the PCEP exam, note that when you see the reassignments, that the latest value is where that variable will point. And that value is the value you will need to use to determine the final output. Python uses dynamic typing, which means you don't have to declare data types. Python infers them. The PCEP will test your understanding of integers, floats, strings, and booleans. Watch for capitalization. True and false must start with capital letters. For example, true or false lowercase will cause a name error. So if we jump into the code here and we assign x, try to assign the value true, not wrapped in quotes, to x with the lowercase t, we get a name error. This is important to know in the PCEP. They may throw this in a code snippet, and you should know that this name error will happen. And it probably will have an answer that says either a name error is thrown or just an error is thrown. Now let's reassign true using capital T to x. Now that value is assigned to x and we can print x, which is true. Readable variable names are a sign of professional code. Python's rules are strict. Names cannot start with numbers and cannot use reserved words like for, if, or class. The PCEP may ask which variable name is valid. Choose names that communicate meaning like failed underscore attempts or source underscore IP, not single letters or cryptic abbreviations. Also, you cannot start a variable with a digit. They must start with an underscore or a letter. You cannot use a keyword, a reserved word. Those will also be trick questions on the PCEP exam. This example ties everything together with a security context. We declare variables, store data, and display output, all using core Python syntax. The PCEP exam includes short code snippets like this and asks you to predict output. Practicing examples like these sharpens both your logic and syntax recognition. On the PCEP, The questions will be more tricky. They will put small little errors in the code to see if you catch them. They'll also leverage the fact that many built-ins have parameters that you should know, especially for the print function. Always remember that the input built-in function always returns a string, even if the user types a number. Python treats numbers with and without decimal points differently. For example, if we just use 4, that's an integer, it's a whole number, and will be type int. If we use a decimal place, it will be a fractional number and will be type float. This small distinction influences results in tasks like calculating average response times or detection rates. The PCEP exam will use operations, mathematical operations, to see if you understand all the rules and semantics about Python. More on that in a minute. Using integers when counting discrete events like login attempts and floats for continuous data such as latency or probabilities is recommended. Integers you should use for counts. Floats you should use for measurements where you want more precision. Remember, floats offer more precision but require more memory and processing. Python's scientific notation keeps your code readable for large or small values. For example, 1E9, and you can use either an uppercase e or a lowercase e for scientific notation, is equivalent to 1 times 10 to the ninth, which is 1 billion, for instance, bytes per second, if that's the measurement we're tracking. 2 to the 5, 2.5 e negative 7 is the same as 2.5 times 10 to the negative 7th, which means this is a very small fractional number. We move the decimal point to the left 7 places and replace with zeros. We use this type of measure for packet loss or something that is very small or very small. In any case, we would use scientific notation for use cases such as bandwidth, key spaces, and precision values. Let's take a look at an example. This example represents an extremely small chance of dropped packets. Python automatically displays floats in compact scientific notation. So we can go ahead and use a variable called packet loss and use scientific notation, which is 2 to the 0.5 e to the minus 7, where e to the minus 7 means move the decimal place to the left 7 places. When we print this, it will use scientific notation. You can also illustrate this a different way. So let's drop into Python 3. So we're in the Python shell, and let me assign packet loss some really small number. Now, if I print packet loss rate, it's going to show the value in scientific notation. This is 7 times 10 to the negative 14th. That means move the decimal place 14 places. So if you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's where I put my decimal place and put a leading 0. This is also a float. So if I do type and on packet loss, you can see it is a float. Remember, we use floats for precision and integers for counts. We just showed this example here in the previous where we created a variable and assigned it to a really small number, and the output, of course, was in scientific notation. So just remember this because there could be a trick question on the PCEP where they assign a variable like packet loss, like this, and somewhere down the way they print it and ask for the expected output. Remember, the expected output will be in scientific notation. When precision matters, we're going to use string formatting for control. To do that, we use what's called an F string. This ensures consistent logging and accuracy in data pipelines. How we do that is we start our string with an F, then we can use double quotes. These curly braces are what's called placeholders. In this case, we're using packet loss rate, colon, and then the format specifier. More about these format specifiers in later lectures, but let's go ahead and use an F string in our previous example here. Just going to go ahead and print here. We'll convert this to an F string. So F double quote curly brace variable name colon format specifier. So I'm going to use the decimal followed by 10 places, and we want to display it as a float, followed by a closing curly brace and a closing double quote. And as you see, we can print this and we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because this is 7 to the times 10 to the negative 14, to see an actual value, we'll have to increase the width here, the number of places. So let's increase that to say 20. And you can see now we have 20 places, and the 7, of course, is in the 14th place. As you review, focus on clarity and repetition. Predict outputs by hand, then test in Python. Build muscle memory for variable naming, assignment, and output. These will appear in nearly every question. The PCEP isn't about tricks, it's about fundamentals. Precision and practice are your best tools. Even though it's not about tricks, there will be many trick questions on the PCEP exam where there's a very subtle mistake that you have to pay attention to detail and capture or detect. You're ready to take the next PCEP prep quiz, quiz number 2. Good luck on the quiz.